Now moving on to the second bit of fifth problem. He has asked us to prove that cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 times secant A. So let us consider the left hand side of given equation, that will be cos A by 1 plus sin A plus 1 plus sin A by cos A. And now let us simplify this, which is equal to, let us take LCM as 1 plus sin A into cos A. Then the numerator becomes cos A into cos A is nothing but cos square A plus 1 plus sin A into 1 plus sin A is nothing but 1 plus sin A whole square. That will be equal to cos square A plus, this is in the form of A plus B whole square, which is nothing but A square, that is 1 square is 1, plus 2AB, that is 2 times 1 times sin A, which is nothing but 2 sin A, plus sin A whole square, that is sin square A whole divided by 1 plus sin A into cos A. That will be equal to, let us write together the terms sin square A and cos square A plus 1 plus 2 sin A whole divided by 1 plus sin A into cos A. Now we have an identity that sin square A plus cos square A is equal to 1. Let us substitute that. Then it becomes 1 plus 2 sin A by 1 plus sin A into cos A, which is equal to 2 plus 2 sin A divided by 1 plus sin A into cos A, which is equal to, let us take 2 common in the numerator, then we get 1 plus sin A by 1 plus sin A into cos A. In the numerator and denominator, 1 plus sin A is common and that gets cancelled. Finally we are left with 2 times 1 by cos A, which is equal to 2 times, we know that 1 by cos A is nothing but secant A. Here finally we got 2 times secant A as answer. Then which is nothing but our right hand side. So here LHS is equal to RHS, and hence we proved the given relation between the trigonometric ratios. Moving on to the fifth question, prove the following identities where angles involved are acute angles for which the expressions are defined. Now moving on to the solution for first bit. He has given an equation and asked us to prove that. Now let us initially consider the left hand side, that is cosecant theta minus cot theta whole square. So let us equate it to, cosecant theta can be written as 1 by sin theta minus cot theta can be written as cos theta by sin theta, and here whole square remains same, that is equal to, in the bracket let us take sin theta as LCM as it is common denominator, then the numerator becomes 1 minus cos theta and its whole square, which is equal to 1 minus cos theta whole square divided by sin square theta. So from the identity we have that sin square theta plus cos square theta is equal to 1, which implies sin square theta is equal to 1 minus cos square theta. Let us substitute it here. Then it becomes 1 minus cos theta whole square divided by 1 minus cos square theta. Here 1 minus cos square theta can be written as 1 square minus cos square theta, which is in the form of a square minus b square, and can be written as a plus b into a minus b. Therefore, that will be equal to 1 minus cos theta whole square divided by 1 plus cos theta into 1 minus cos theta on splitting the 1 minus cos square theta. Here, if we observe numerator and denominator, we have common factor 1 minus cos theta, which cancels 1 minus cos theta square 1 minus cos theta times. So finally we got 1 minus cos theta by 1 plus cos theta, which is our right hand side. So here we got LHS equal to RHS. So finally we can say that cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Moving on to the fourth bit of the fifth question. Here he has given an equality of two expressions, that is 1 plus secant a by secant a is equal to sin square a by 1 minus cos a. So let us move on to the solution. As he asked us to prove the equality, let us consider the left hand side. And simplify it, then right hand side and then simplify it. If they are equal, then the equality is right. So in the left hand side, the given expression is 1 by secant a whole divided by secant a. That will be equal to 1 plus secant a can be written as 1 by cos a whole divided by secant a, here also can be written as 1 by cos a, which is equal to, let us take cos a as LCM in the numerator, then we get cos a plus 1 in the numerator divided by cos a whole divided by 1 by cos a. Here in the denominator of the numerator we have cos a as common, so these two will be cancelled, and finally we are just left out with cos a plus 1, which can be written as 1 plus cos a. So here the simplified form of left hand side is 1 plus cos a. Similarly, let us also simplify right hand side, that is sin square a whole divided by 1 minus cos a, which is equal to, here we have an identity that sin square a plus cos square a is equal to 1, which implies sin square a is equal to 1 minus cos square a. So by replacing sin square a as 1 minus cos square a divided by 1 minus cos a, that is equal to, here this can be written as 1 square minus cos square a, which is in the form of a square minus b square, that can be written as a minus b, that is 1 minus cos a, into a plus b, that is 1 plus cos a, whole divided by 1 minus cos a. Here in the numerator and denominator we have 1 minus cos a as common, and that will be cancelled, and finally we are left out with 1 plus cos a. So the simplified form of LHS is equal to the simplified form of RHS. So the equality 1 plus secant a by secant a is equal to sin square a by 1 minus cos a is correct. Now moving on to the 10th bit of 5th question. Here he asked us to prove that 1 plus tan square a by 1 plus cot square a is equal to 1 minus tan a by 1 minus cot a whole square is equal to tan square a. In order to prove this equality, let us prove that first expression is equal to last expression and second expression is equal to third expression. Thereby we can say that all the three expressions are equal. So let us consider the first part, that is 1 plus tan square a by 1 plus cot square a, which is equal to 1 plus tan square a whole divided by 1 plus cot square a can be written as 1 by tan a whole square, that is nothing but 1 by tan square a. So now that will be equal to 1 plus tan square a whole divided by, let us take the LCM as tan square a in the denominator, then the numerator of the denominator becomes tan square a plus 1. Here in the numerator and denominator 1 plus tan square a is common and that will be cancelled. So finally we are left out with tan square a. So here we proved that 1 plus tan square a by 1 plus cot square a is equal to tan square a, which is our first proof. And secondly, let us consider 1 minus tan a by 1 minus cot a whole square, which is equal to 1 minus tan a by 1 minus cot a can be written as 1 by tan a whole square, that is equal to 1 minus tan a by, if we take tan a as LCM here, then the denominator becomes tan a minus 1 whole square, which is equal to, let us separate the tan a here, then it becomes tan a whole square, which is nothing but tan square a into 1 minus tan a by, if we take minus common in this, then it becomes 1 minus tan a as denominator whole square, which is equal to tan square a into, here this will be cancelled and this will be cancelled as it is common in numerator and denominator, and we are left out with minus 1 whole square, which is equal to minus 1 whole square is nothing but 1 and 1 into tan square a is tan square a again. So 1 minus tan a whole square by 1 minus cot a, and whole square is for both, is equal to tan square a. Let this be our second equation. From 1 and 2 we can say that 1 plus tan square a by 1 plus cot square a is equal to 1 minus tan a by 1 minus cot a whole square is nothing but tan square a. Now moving on to the 8th bit of 5th problem, let us find the solution for this. Here he has given an equation, that is sin a plus cosecant a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. In order to prove this, let us initially consider the left hand side. That is sin a plus cosecant a whole square plus cos a plus secant a whole square, which is equal to, this is in the form of a plus b whole square and this is also in the form of a plus b whole square. Let us apply the formula that a plus b whole square is equal to a square plus b square plus 2ab. Then we get here sin square a plus cosecant square a plus 2 sin a into cosecant A. Here this can be written as cos square A plus secant square A plus 2 times cos A into secant A. That is equal to, let us write sin square A and cos square A together, plus cosecant square A plus secant square A together, plus here 2 times sin A times cos A is nothing but 2, as sin A into cosecant A is 2, plus similarly 2 times cos A into secant A is equal to 2, as cos A into secant A is nothing but 1. So finally here, as we know from the identity 1 that sin square A plus cos square A is equal to 1, by replacing it we get 1 plus 2 plus 2, that is 5, plus cosecant square A plus secant square A, which is equal to 5 plus, from the two identities, that cosecant square A is equal to 1 plus cot square A and secant square A is equal to 1 plus tan square A. By substituting it here, we get the expression in terms of tan square A and cot square A. That is, cosecant square A can be replaced by 1 plus cot square A plus secant square A can be replaced by 1 plus tan square A. That will be equal to 5 plus 1 is nothing but 7 plus cot square A plus tan square A, which is nothing but our right hand side. So here we got LHS is equal to RHS, and hence we proved that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Moving on to the fourth bit of the fifth question. Here he has given an equality of two expressions, that is 1 plus secant A by secant A is equal to sin square A by 1 minus cos A. So let us move on to the solution. As he asked us to prove the equality, let us consider the left hand side. And simplify it, then right hand side and then simplify it. If they are equal, then the equality is right. So in the left hand side, the given expression is 1 by secant A whole divided by secant A. That will be equal to 1 plus secant A can be written as 1 by cos A whole divided by secant A, here also can be written as 1 by cos A, which is equal to, let us take cos A as LCM in the numerator, then we get cos A plus 1 in the numerator divided by cos A whole divided by 1 by cos A. Here in the denominator of the numerator we have cos A as common, so these two will be cancelled, and finally we are just left out with cos A plus 1, which can be written as 1 plus cos A. So here the simplified form of left hand side is 1 plus cos A. Similarly, let us also simplify right hand side, that is sin square A whole divided by 1 minus cos A, which is equal to, here we have an identity that sin square A plus cos square A is equal to 1, which implies sin square A is equal to 1 minus cos square A. So by replacing sin square A as 1 minus cos square A divided by 1 minus cos A, that is equal to, here this can be written as 1 square minus cos square A, which is in the form of A square minus B square, that can be written as A minus B, that is 1 minus cos A, into A plus B, that is 1 plus cos A, whole divided by 1 minus cos A. Here in the numerator and denominator we have 1 minus cos A as common, and that will be cancelled, and finally we are left out with 1 plus cos A. So the simplified form of LHS is equal to the simplified form of RHS. So the equality 1 plus secant A by secant A is equal to sin square A by 1 minus cos A is correct. Now moving on to the 7th bit of 5th problem. He has asked us to prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. In order to prove this, let us consider the left hand side, that is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta, that is equal to, in the numerator let us take sin theta common, then we get the numerator as sin theta into 1 minus 2 sin square theta divided by, in the denominator let us take cos theta as common, then we get the denominator as cos theta into 2 cos square theta minus 1, that is equal to, if we write sin theta by cos theta separately, then it is nothing but tan theta into 1 minus 2 into, here we have an identity that sin square theta plus cos square theta is equal to 1, which implies sin square theta is equal to 1 minus cos square theta. Let us substitute here, then we get 2 times 1 minus cos square theta divided by 2 cos square theta minus 1, which is equal to tan theta into 1 minus 2 times 1 is 2, and minus 2 times 2 square cos theta is plus 2 cos square theta divided by 2 cos square theta minus 1, which will be equal to tan theta times, here by rearranging the terms we get 2 cos square theta minus 1 by 2 cos square theta minus 1. Here in the numerator and denominator we have 2 cos square theta minus 1 as common, which will be cancelled, and finally we are left out with tan theta, which is our right hand side. So here as LHS is equal to RHS, we can say that sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta is equal to tan theta. Now moving on to the 5th bit of 5th question, he has given to prove the equality of cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosecant A plus cot A, using the identity cosecant A is equal to 1 plus cot A. Now moving on to the solution. Let us consider the left hand side, that is cos A minus sin A plus 1 divided by cos A plus sin A minus 1. As here he asked us to prove the equality using identity cosecant square A is equal to 1 plus cot square A. Let us convert the given expression in terms of cosecant and cot A. In order to do that, divide both numerator and denominator by sin A. Then we get the expression as cos A by sin A minus sin A by sin A plus 1 by sin A whole divided by cos A by sin A plus sin A by sin A minus 1 by sin A, which is equal to cos A by sin A is nothing but cot A minus sin A by sin A is 1 plus 1 by sin A is nothing but cosecant A whole divided by cos A by sin A is again cot A plus sin A by sin A is nothing but 1 minus 1 by sin A is nothing but cosecant A. So the expression will be equal to cot A plus cosecant A minus 1 by cot A minus cosecant A plus 1, which is equal to, as he asked us to use the identity that cosecant square theta is equal to 1 plus cos square theta, or cosecant square A is equal to 1 plus cot square A. Let us replace 1 by cosecant square A minus cot square A, that is equal to cot A plus cosecant A minus 1 we shall replace by cosecant square A minus cot square A whole divided by cot A minus cosecant A plus 1, which is equal to cot A plus cosecant A, let it be in one bracket, minus, this is in the form of A square minus B square, that can be written as A plus B into A minus B whole divided by cot A minus cosecant A plus 1, which is equal to, let us take here common as cot A plus cosecant A whole of 1 minus, here we will be left out with cosecant A minus cot A whole divided by cot A minus cosecant A plus 1, that will be equal to cot A plus cosecant A remains as it is, and this expression can be written as 1 minus cosecant A, and minus into minus is plus here, and by rearranging them we can write it as cot A plus, that is cot A minus cosecant A plus 1 whole divided by cot A minus cosecant A plus 1. Here cot A minus cosecant A plus 1 is common in both numerator and denominator, that will be cancelled. So finally we are left out with cot A plus cosecant A, which is nothing but our right hand side. As LHS is equal to RHS, we proved the equality. Moving on to the third bit of fifth problem, let us find the solution. Here the given equation is tan theta by 1 minus cot theta by 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. Now in order to prove this, let us consider the left hand side. That is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. So let us write tan and cot in terms of cos and sin, so that our calculation could be made easily. So we know that tan theta is nothing but sin theta by cos theta whole divided by 1 minus cot theta is nothing but cos theta by sin theta plus cot theta can be written as cos theta by sin theta whole divided by 1 minus tan theta is nothing but sin theta by cos theta, which is equal to, so sin theta by cos theta, let it remain as it is, And in the denominator, if we take sin theta common, then we get sin theta minus cos theta whole by sin theta plus cos theta by sin theta. Let it remain same in the numerator, and in the denominator we get, if we take cos theta as LCM, cos theta minus sin theta whole by cos theta. Now in these two terms, if we observe clearly, we can take common 1 by sin theta minus cos theta. So by taking 1 by sin theta minus cos theta common, we get inside the bracket numerator sin theta by cos theta remains same, and if we send sin theta to top, then it becomes sin square theta by cos theta plus, and here it will be minus 1 as we took sin theta minus cos theta common. So if we send cos theta to top, then it becomes minus cos square theta whole by sin theta. Now that will be equal to 1 by sin theta minus cos theta into sin square theta by cos theta minus cos square theta by sin theta. That will be equal to 1 by sin theta minus cos theta whole into, let us take LCM here, sin theta into cos theta, then we get sin cube theta minus cos cube theta as numerator, which is equal to 1 by sin theta minus cos theta whole of, this is in the form of a cube minus b cube, which can be written as a minus b, that is sin theta minus cos theta, into a square, that is sin square theta, plus b square, which is nothing but cos square theta, plus ab, that is sin theta into cos theta, whole divided by, the denominator remains same, that is sin theta into cos theta, which is equal to, here in the numerator and denominator, sin theta minus cos theta is common, and that will be got cancelled, and here we have an identity that sin square theta plus cos square theta is equal to 1. Let us substitute that becomes 1 plus sin theta into cos theta whole divided by sin theta into cos theta. Let us separately divide it, then it becomes 1 by sin theta into cos theta plus sin theta into cos theta whole divided by sin theta into cos theta. Here 1 by sin theta into cos theta can be written as 1 by sin theta into 1 by cos theta, which is nothing but 1 by sin theta can be written as cosecant theta into 1 by cos theta can be written as secant theta, plus as a numerator and denominator are common, that value will be equal to 1. So which is finally equal to 1 plus cosecant theta into secant theta, which is our required right hand side. So here we got LHS is equal to RHS, and given equation is hence proved.